All right, let's explore the basics of sampling within R. And in order to do that, what we'll do is we'll actually kind of build up an example of kind of a conceptual jar, and we'll sample out of that jar. So in order to do that, the first thing we'll do is we'll create a variable called jar, and we'll have two values, two elements in that vector. So we have a vector jar with just two elements, a 0 and a 1. So the 0 kind of represents red, and the 1 represents blue, for example, or vice versa. So we'll just kind of have jars with 0s and 1s, and we'll be pulling out a 1 or a 0 kind of repeatedly. So we can create a variable called numSamples, which will be how many times we actually sample the jar. And then we can actually try to do a sample. So we can sample the jar, samples times, we can have replace equals true. So what do you think that this line of code actually does? Well, we can see that it returns a vector of 4, and each element of the vector is a sample of either 0 or 1. If we do it multiple times, we're going to get different 0s and 1s, different combinations of 0s and 1s, because we continue to sample. So in this time we got a 1 and 3 zeros, for example. This time we got 3 zeros and a 1. So the sampling process is different each time, and because replace equals true, we're able to do that sampling. If replace equals false, what do you think this will do? That's right, it's an error because numSamples is more than the number of samples in the jar. So if we were to do this, we only draw out 1, for example, that's okay. In fact, we can even do it twice because there's two in the jar. So if we do this twice, what will we get this time? Yep, a 1 and a 0. And by definition, it's always going to be a 1 and a 0. Might be in a different order, but it's always going to be a 1 and a 0. That's because we're pulling out the 0, and then whatever's left, we're pulling that out. So we can kind of know that's the case. But as we go forward here, we'll kind of replace equals true, and we'll just kind of keep sampling from the jar like this. See, that's pretty rare. 4 zeros. It happens, but it's not that often. Now we can kind of do different operations on this. So for example, we could calculate the sum of the vector. So that means 3 out of the 4 were 1s. Do it again. Only 1 out of the 4 were 1s. Instead of doing a sum, it might be easier to conceptually think about doing a mean. So this means half of the time we sampled a 1 and half the time we sampled a 0, because the mean was 0.5. This times 3/4 of the time it was a 1, and 1/4 of the time it was a 0. Again, kind of 1s and 0s are the same as like red and blue balls in a jar. So now we can also repeat this process of sampling multiple times. So we can go back to our simple sample code. So again, we're sampling just 4 times. Now we can say, let's do this, or replicate this, say 5 times, and we'll have simplify equals true. So now we did this sampling. Each sample is a column. So that's 1 set of samples, 2 set of samples, 3, 4, and 5. And because simplifies equals true, it's kind of like a data frame. You're probably curious what simplify equals false looks like. It's the same data, it's just more of this than a data frame. Instead of 5, now if we did 2, for example, we're going to have 2 columns. Okay, so now basically what we're doing is just repeating this process, whatever's in here, we're repeating that process that number of times. So how about if we, instead of just doing a sample, made this be the mean of that whole thing. So what will this return? That's right, it returns 2 means. So rather than full list, it returns 2 because we had replicate equals 2. So if we have this be 10, for example, it's going to give us 10 different means. We can store this result in something called a variable called variable sample means. And here, let's take this whole line of code, stick that down there. So now we have a variable sample means. See up there, it's 10 numbers varying between 0 and 0.75 based on how many times we're sampling. And we can do different things with these sample means. So for example, we can take a mean of our sample means. So this is the overall average. And remember, we would expect it to be half zeros and half ones to be 0.5. So if we repeated this with 100, see now we're closer. We can also do things like standard deviation to get a feeling for how spread out things are. So that's the standard deviation. And if we made it back to 10, standard deviation is larger, right? Because we've done it less frequently. So we'd expect more variation in the numbers. We can also do a quantile to kind of get a feeling of the range that way. Sample means. And then we'll do it, 2.5, so kind of at 2.5 and that percentage. There we go. So we can kind of see that the top 2.5% were 1, and the bottom 2.5 were close to 0, just based on kind of what this number's meant. We can kind of go back and make this a much larger number, for example. Maybe what we can do with sample means. Obviously, we can do a mean. Getting closer. We can also do a histogram. See the distribution. See, it's kind of like a nice bell-shaped curve, but because we're only doing num samples was 4, right? Yeah, num samples was 4 up here. You can see. So we don't have the full spectrum. So if we wanted to get you can change this num samples to be more samples from the jar each time and then repeating that. So let's have num samples equals 50. Now let's take a mean of the sample means. Ah, much better. And if we do a histogram of sample means, see that? We can even see. Now let's see here. Let's change this. Take a mean of sample means now. It's still fairly close because we've done so many samples each time to generate a mean, then we're just averaging those. And if we want to generate the histogram, not as good, obviously, right? So you have a trade-off, how many times you're replicating and how many times you're sampling beneath the jar. Obviously, if you increase both, you're going to get a more kind of accurate understanding of the distribution of the jar. And if you only increased how many times you're replicating, you're still going to have this sampling issue down here, as we kind of saw in that distribution. So maybe now I'll ask you to kind of do a simpler problem and maybe try to create a jar variable with 3 values, -1, 0, and 1, and then sample that jar 250 times. And what's the mean? So let's write that code. So we'll have a new jar, another variable. Now instead of just having 2 values in the vector, we're going to have 3 values in the vector. We'll have new num samples. I said 50 times. And then we'll have create a vector of the samples. We'll have sample of the new jar, new num samples. And I didn't really specify this, so replace equals true. You kind of need to have that if you want to do 50 samples, right, as we saw before. And now the last step is the mean of S, 0.24. Now, of course, if I can combine these two. So rather than storing this, do a mean. So we would expect it to be around 0. The first one, it was a little bit higher than average. That means we got more ones and zeros, and a lot less minus ones, for example. And we could take a look at the histogram of S. Remember that S is what generated this 0.25. And you can see it's kind of all over the place with a lot of ones and a lot of zeros, less minus ones, which kind of shifted everything over. All right, I think we'll stop there for this session. I think you guys have a pretty good feel of sampling from jars using R.